Welcome back to the metaprogramming tutorial with rlang, and I was now able to avoid it for 6 sections, but now I can't avoid it any longer. Let's have a look at terminology. It helps you to just get a little bit more structure in your understanding of metaprogramming, and it helps you to understand the following 4 sections. Yeah, let's start with a concrete example. Here what you see is just a vector. It's not related to metaprogramming, so it contains an NA and when all the numbers starting from 1 up to 10. And now we have some source code. It's a sum instruction making use of this vector and specifying NA remove as false. So if you just evaluate this one, you will receive NA because one of the elements is NA. And now let's have a more detailed look at this expression. So the whole thing here, the whole thing this is what we called expression before, but we can also call it a function call or just a call. And such a function call has different parts of which it contains. So the easiest parts are constants. Such a constant is highlighted in yellow here. A constant is always a fixed value, so it can be false, for instance. It can also be just a number. It can be a character, or it can also be null. But in all cases, such a constant has the length of 1 or maybe of 0 if it's null. But in all the other cases, it's really length 1 and it cannot be longer. And in addition to constants, there are also symbols, and there are 2 types of symbols. One type of symbol is the actual name of the function. In this case, it's sum, and also this object is a symbol. And it's a symbol in both cases because it's not directly stated as constant, so you really see what's inside. Here it's false or it's a 2, but you have to follow a certain reference in order to find out the value of int for nums. So it's not final, you still have to look inside, and you also have to look inside your memory in order to find the definition of this function. So it's not a constant, it's rather a reference to something. So these are the three parts of which an expression can consist. The whole thing is a call. A call can be a symbol or a constant. And both constant and symbols are always have length 1. Let's have a look at a more complex example, this one up here. It does not look like a call, but it is actually a call, and it becomes more obvious that it's a call if you just rewrite it using the so-called prefix notation. And because everything in R is a function, you always can write it as a function, and even this assignment operator, it's also a function, and you can just write it differently by making use of these ticks and write it as the first element of your call. So the function is no longer sum as in the previous example, it's rather this assignment operator. And because it makes use of special characters, you just have to make use of these ticks. This is the rule in R. The first parameter is actually the variable which you want to make use for assignment. So this is where the value is assigned to. And this is actually int nums p2. So this is the first parameter. And if you have a second look at it, the second parameter is a call itself, because it's not just 2, but it's actually the sum of int for nums and 2. So this is once again a call, a subcall, and you can also write it using the prefix notation. So you just write plus as the name of the function. The first parameter is this, and the second parameter is the 2. So you see that the second parameter of the assignment operator is itself a call, is itself an expression. So you can, I've shown you this in order just to make clear to you that everything you see in R can be captured as an expression, and everything can be described making use of symbols. So the functions are once again the symbols, and the names of the objects are once again the symbols, and of constants. And the whole thing is a call, and a call can itself consist of subcalls or of symbols and constants. And how is it all related to expressions? So I already told you that what we call what is named call here. This is what we called expression on the previous slide. So each call is an expression, and this is why you can write the whole call making use of this expression method here. And you can also create the symbols and also the constants making use of the expression. So you see that, for instance, you could just write expression of sum in order to create this function as an expression and to refer to it, for instance, using the bang bang operator. And you can also create the object as a symbol and write expression of inf nums. But because it's a symbol, there's also another way to put it. And another way to put it is making use of the symbol method, which is new. And you can just say, instead of expression info nums, you can just say sim and then put info nums in quotation marks. This is possible as well. So if it's not such a complex call consisting of several parts, but if it's just a symbol, you can also make use of this symbol method as well. And constants can also be expressed making use of this expression comment by writing expression of x or expression of 77 or expression of false. This works as well. But in case of constants, it's actually not necessary. You can just write false and make use of constants without actually using expression. What I have not mentioned is pair list. Pair lists are used in order to specify parameters of new functions, but this is almost never used based on my experience, so I just added here for the sake of completeness, but we won't have a look at it on the following slides. Okay, let's maybe have a look at the difference between expression and sim, because I showed you here that in order to state symbols, in order to define new symbols, you can both make use of the expression command and of a sim command. So let's have a look at different usages of these two methods. So you can, in order to create symbols, and we are only talking about symbols, not about calls and not about constants, you can either create an X symbol by specify it as a character string and use sim, or making use of expression without providing X as a character string, but just write X. If you are inside a function and X is actually the name of a parameter of a function, then make use of an expression and an sim in order to make sure that you actually get the content of X as an expression and not X itself. And yeah, if you know how such a call is structured, and if you know all these constituting parts, you can access the different elements of a call. So once again, here's the call, expression of a sum, and you can actually access the name of a function or the symbol which is behind the name of a function by just accessing the first element like you do it with lists. So so in order to represent the expression, R actually makes use of a structure which you already know from lists. So if you just want to access this first element here, which is highlighted in blue, just specify a 1 inside these brackets here, and you will receive this symbol and know that, okay, it's all about executing a sum. If you want to see the first parameter, please make use of, please access the second element of this list and you get info nums. And you can access this constant by having a look at the third element, which is false, and then you get the constant. So you can not only specify new symbols, new calls, and new constants, but you can also take an existing call and just extract the consisting parts. And in the next chapter or in the next section, I will actually show you how you can replace these elements in order to modify such a call after it has been created.